Welcome guys in this session. Today we are going to discuss about the 4:1 multiplexer. We will draw the sketch of 4:1 multiplexer using the CMOS inverter circuit and pass transistor logic circuit. Both the circuits we will discuss here, how we can make the sketch of 4:1 multiplexer using CMOS inverter and only pass transistor logic where NMOS transistor is used. So this one is the 4:1 mux diagram, or here these are the inputs, 4 number of the inputs, I0, I1, I2 and I3, and here on the above there are the two select lines, S0 and S1. This one Y is the output. So how we can choose these inputs? 4 inputs means how many inputs we can consider in the 4:1 multiplexer or other. How we can know this? So according to this formula, 2 raised to power n, where the n is the number of the select lines, and this whole formula 2 raised to power n is the number of the inputs. So if the n is 1, then this 2 raised to power 1 is equal to 2, then only one select line is there. This is 2:1 multiplexer, and in this 4:1 multiplexer this n is 2 raised to power 2, this 2 is the select lines, and 2 raised to power 2 to the power 4, this 4 are the inputs there, and y is the output of this 4:1 multiplexer. So next one is the truth table of this 4:1 multiplexer. Here the inputs I0, I1, I2 and I3. For all these inputs, they may be 1 or 0, all the inputs. So these are the select lines, S0, S1. So these are 0, 0, 0, 1, 1, 0 and 1, 1, the value of these select lines, binary values. And the output Y is when the select lines are 0, 0, S0 and S1 both are 0, 0, then the output is decided, and it considers the value of the I0, that is I0. So when the select lines are 0, 1, then in the output that is the value of I1, it may be 0 or 1, and when the select lines are 1, 0, then the output value Y is the I2, and when the select lines are 1, 1, then in the output it will get I3. So according to this truth table, we will make the sketch of this 4:1 multiplexer in both CMOS inverter logic and pass transistor logic. So here in the pass PMOS logic, here are the two types of the transistor are used, two types of MOSFETs are used in the CMOS inverter. One is the PMOS inverter, PMOS MOSFET, and other one is the NMOS MOSFET. So in the PMOS MOSFET, this will on when the zero logic is applied at the gate terminal of this PMOS, and when we apply one logic at the gate of this PMOS, it will be off. So similarly the NMOS, that is equally opposite to this PMOS. So this for NMOS. So when we apply the zero logic at the NMOS, it remains the off state, and when we apply the one logic at the gate terminal of this NMOS, then it will be on. So according to this truth table, we have make these two equations. So one thing more, in the PMOS, when we apply the zero logic at the gate terminal of this PMOS, then we will represent this non-complementary, this component means if the value of S0 is 0, then it will be only S0, not S0 bar, and when we apply the one logic at the gate terminal of PMOS, then it will be, suppose as an example for this, here the S1 is, when we apply this S1 value 1 at this PMOS terminal, then we represent this S1 complement, this like this. So this is equally opposite to in the NMOS. Similarly, in the NMOS, 1 represent the non-complement and 0 represent the complement. So here 1 and 1 both are select lines are 1, and in the NMOS these both represent only S0 and S1, and for 0 0 in the NMOS both represent the S0 complement and S1 complement. This is the important thing in the sketching of the circuit. So firstly we will draw the CMOS inverter circuit, then we will draw the pass transistor logic circuit here. So let's move to the CMOS. So firstly, what is a CMOS? Basically CMOS is look like this. So this is tilting CMOS. This bubble represents the PMOS. This is the PMOS. These are the inputs of the both the gate terminal. From both the gate terminals, this is the PMOS, this is NMOS. When we apply the zero logic on this input side, this PMOS goes on and this will be off. And when we apply the logic 1 at this gate terminal, this NMOS will on and this PMOS in the off state. So this behaves like a NOT gate. When we apply the 1 at the input, then it gives the output 0, and when we give the 0 logic in the input, then it will be, the output will be 1. So this behaves like a inverter or NOT gate. So I have make the two equations here, that is from this truth table according to the K map. So product of sum and sum of product type two equations. This first one is the POS, product of sum, POS, and this one is the SOP equations. So POS equations for PMOS, this equation means here the when we POS product of sum, firstly we will give the product, then we do the product of sums. Firstly we do the product of, we do the sum of these inputs. So S0 plus S1 dot, this will represent the product, then with I0, and then dot I1, this will be multiplied with both these S0 plus S1 complement in the PMOS. 1 will represent the complement in the PMOS, then dot again product, then for I2 this, and this will multiply both these, and S0, 1 will represent the complement in the PMOS, S0 complement plus S1, then dot again for fourth input of this select lines, I3 multiply with S0 complement plus S1 complement, and this will be the POS product of sum equation. And according to this equation we will make the PMOS or pull-up circuit in the in the sketch of CMOS inverter. And for NMOS we will follow this SOP equation, sum of products. First we will do the product of these select lines with multiplication of this input, and then for next input we between the first and second input we do the sum of the equations. And this is opposite in the PMOS. First we do the product of for first input, and between the first and second input we what we are doing, we are doing the product between the two inputs, and this I1 is multiplying the serial wise their input of select lines. So here firstly we will follow the this for PMOS we follow this PMOS pause equation. So here one thing we need to remember, all the addition components, that components that are added to each other, we draw that component in series, and the component that are that are doing the product each other, that component we will represent here in the circuit that are in parallel. So first one by one we will represent. So first one for this I1 is making the product for both these S0 and S1 here for product of some pose equation. So here we will first represent the pause for PMOS. This bubble represent the PMOS. So S0, this will be the S0. Second, this is addition is in the series. Then S1, S0, and this one will be the S1. So this S1 and this both are multiplied with I0. So I0 is in parallel in both these. So this will be the parallel in both these are in PMOS. So this is the, what is this? This is I0. So this first one is this, second one is dot means multiply, and that is in parallel with this second equation. This is in parallel with second, then S0, S1, S0, S1, and parallel with I1. I1 is multiplying both these. So firstly I am drawing this and then this. So this is the S0 and S1 complement, and parallelly drawn, that is I1 in PMOS, and these are connected to each other from the upper side. This one will be the I1, and third again multiplying the third equation with I2, and first I will draw this inner bracket, that is PMOS of this, and then this is parallel with I2, and this is S0 complement and S1. This one is the S0 complement and this one is S1 only. So and now the last fourth, this firstly solve the inner bracket. So inner bracket, that is this PMOS represent the S0 complement, this PMOS represents the S1 complement, and in the parallel this one is the I3. So this one, and this all will connect from the upper side in the parallelly in the this all represent the pause equation in the PMOS. These all the PMOSFETs are connected. So here, so from bottom, this will also all the connected to each other from bottom side. This is the pull up circuit of this 4:1 multiplexer, total 1 2 3 3 9. So total 12 MOSFETs are used here, and in the PMOS. And now we are going to draw the sketch of NMOS, the pull down network with the change of color. So here we will draw the now we will follow this NMOS SOP equation, sum of product equation. Same rule apply here, but here the same rule here, the product terminal are connected in the parallel and some terminal are connected in the series. So only changing in the complement and non-complements, means this S0 is represented in the upper here without complement, but here is representing the complement. Only this changing is considered in this NMOS. So we follow this equation. So firstly firstly we draw the sketch of from inner bracket components. So S0 component, this is NMOS, no bubble here, and the S0 component, this is parallelly connected with S1, so it will this, and S1 complement, S0 complement, S1 complement, so this will connect it from bottom, and I0 is also parallelly connected with this. So here is the I0. The second one is the plus, and then addition is there, no addition is there. So after that plus, no the next circuit is in the series. Next equation is next equation, this equation circuit is in series of this first equation circuit. So next is S0 again, here the S0, and this one is the S0 complement, and this one will the S1 only. So this and this will parallelly connected with I1, this I1, and this is also connected from middle. And now the third one is the here, third one, this S0 and S1 complement, these are both are parallel to each other, means dot in between. Here S1 complement and S0, these are connected to each other, and the next one, that is I2, is parallelly connected to this I2 is parallelly connected with this, and this will connect this. And last one is the S1, here S0, here S1, this will connect it to this will connect it to this, and the I3 is parallelly connected with this. So here this is the I3, so this is connected with middle from this above circuit, and this will connect it to ground, and this will connect it to this from middle of this pull up network above, and this below is the pull down network, and this is from this we take the output Y. And now what we will do, we will join this the inputs. Firstly I0 to above I0, this above I0 to below I0 we will join with this input. Second I1 we will join with this this will join with this I1, this I2 will join with this. Basically what we are doing here, this above is the PMOS, this below is the NMOS. So when PMOS and NMOS are connected in series, so it behaves like an inverter. So here this also behaves like an inverter. What we are doing, we are only connecting PMOS and NMOS to each other in series, so it behaves like an inverter circuit. So last one, I3 will be connected with this. So these inputs are connected to each other, these inputs. Now the select lines remaining. So what we do, first change the color of this and this color, and we will connect. Firstly we will connect this S0 of this first S0. This will connect from this S0 to this PMOS is connected to this NMOS. This S1 is connected to the below S1 last of the same. This PMOS and NMOS are connected. These both are behaves like an inverter. So the second equation is connected with the second one. This from S0 is only connected with S0, and S1 is also connected with this S1 complement. This one is the S1 complement is connected with S1 complement. So for third equation, S0 complement is connected with this S0 complement, and this S1 is connected with this S1, and last one is this is the S0 complement, and this S0 complement will connect with this S0 complement, and this S1 complement is connected with this. So these are these PMOS and NMOS are connected to each other as an inverter. So PMOS and NMOS are connected in series in this 4:1 multiplexer circuit using CMOS inverter. So this is the output. We take the output from this. So when in this circuit so firstly this is the equation, first equation, and PMOS and NMOS. This is the first equations, means this equation represents this S0, and this S0 and this S0 and this S0 will connect. This S1 and this S1 will connect. So similarly this I0 and this I0 will connect, and similarly this will connect this will connect this, and these are connected PMOS and NMOS. So when we according to truth table, when there will be here this is the S0, this is the S1. For combining of this S0, input is going to the both PMOS and NMOS gates. This S1 input is going to both the PMOS and NMOS gates. Similarly this I3 is also for both the PMOS and NMOS. This I2 is also for both the PMOS and NMOS. This I1 is also for both PMOS and NMOS, and this I0 is also for both the PMOS and NMOS. So here S0, S1, and this is the this one is the S0 complement, and this one is the S1 complement. So all be same as all these different inputs here. So when we give the input 0 0, suppose S0 and S1, when we give the input S0, so S0 and S1, so when both are in case of PMOS, when we give the 0 0, the only PMOS will on, and in the inverter circuit, but NMOS remains off in off condition. And when we give the 1 1 logic at both the S0 and S1, means this input will follow, then only the NMOS, this pull down network circuit, only NMOS will on, and in the output we get the this I3. So when the S0 and S1 are 0 0, we get the in the output is I0, this, and when the S0 and S1 are 0 1 in these inputs, so means when this S0 will active, S0 in case of PMOS, when this S1, this S1 complement will active and S0 this active, then we get the in the output at I1. So Y will be selected to the I1. Similarly, when the S0 1 and S1 will 0, means this type of inputs are active, then in the output the I2 will be selected. And similarly, when the S0 and S1 means both are 1 1 active in the from all these inputs, then these 8 inputs, and then we get the I3 at the output. So this is the CMOS inverter circuit for 4:1 multiplexer. Now we will draw the sketch of CMOS 4:1 multiplexer using transmission gate. So transmission gate is only in the form of NMOS. So here firstly we make the equation for that. Here from the truth table, here the S0 have only two conditions in S0 for when S0 have two conditions 0 0 and 1 1, means first one is in case of NMOS, and this is the complement. In case of NMOS, 0 will be the complement and 1 will be the non-complement. So when the S0, when we write the S0 complement, then it will be 0, and when write the S0, then it will be 1, logic 1. It represents the logic 1. So in this pass transistor logic, so it has only two conditions, S0 0 and 1s, and in the second select line S1, it has the it has two conditions 0 and 1. It has four conditions 0 1 0 1. So according to these select lines, the output will be selected from these inputs. So this we write the, we always give from right to left during making this circuit of 4:1 multiplexer or any multiplexer using transmission gate. So firstly we make the this circuit, this is the control signal. We give the input on this signal, and these are the input, and this is the output. This is the control signal. We give the logic at this signal, this state. So here there are the two states only for S0. This is the S0 complement and S0, means S0 complement means this is 0, and for S0 only where is selected the 1 1s. zeros and ones for this, and next one for this next S1 stage, this will move to this, and here the this circuit I have only make for showing the pass transistor look like this. So I don't need here this. I want to remove this from here. So this pass transistor and this pass transistor represents the these 200 means first two inputs of select lines, first two values, and this bottom pass transistor represents the bottom two logics, two values of only S0 select line. So this represents the 1, this represents the zeros. So let's move to this next input. So here also have the two logics there, 0 1 and 0 1. So here this will represents the S1 complement, and this will represent the S1 only. S1 only. This, sorry for that, this will this S1. So this will connect it to each other, and this will go to this. So these first two pass transistors are representing the this two second select line, two values 0 and 1. This represents S1 complement, represents this above 0, and this bottom represents the this 1. And similarly for bottom, for this, when the S0 have 1 1, then S1 have two values 0 and 1. So we need to draw the two sketches there of pass transistor that represents the also 0 and 1. So here represents the S1 represents the S1 complement. Here represent S1. What is S1? S1 complement means S1 has value 0 in case of pass transistor. So this will be the complement here, and in the bottom this will be the 1, and this will without complement. So this will connect it to this, and here this first one is the I0, second one I1, third one will be the I2, and fourth one will be the I3, and from here we get the output Y. So this is the pass transistor circuit. So when from truth table, when I am explaining here, when the input I0 and the select lines are 0 0, both are 0 0 means both select lines are 0 0 means S0 and S1 both are complement. This one will be selected S0 complement this, and from here S1 also complement this first two here, and in the output it detects only I0. Similarly, when the S0 remains same S0 complement, this will remain same S0 complement, and S1 changes to 1 logic, means this S1 complements only S1, not complement, only S1. So it will, when the S1 and S0 means S1 means it 1 and S0 complement means 0, then it detect the I1 at the output. Similarly, so no, this part is explained. No, I am going to this part, and then when the S0 is 1 means S0, only S0, not the S0 complement, only S0. When there is only S0 this, and in the S1 for second select line it has a 0 means S1 complement. So this, so it detects the I2 input. So when this path is considered in the output, and in the final when the S0 will 1 and S1 will 1 mean both are non-complement, then S1 and S0, then it will detect the I3 in the output. So this is the pass transistor logic circuit. So all this in the today lecture. So guys, if you really learn something from this video, so please subscribe my channel and like the videos and comments. So thank you guys.